All right. What did we talk about last time was user frame, right? Today's tool frame. So if you noticed, when I jog the robot in world, remember the bottom three axes, which is the Y, W, P, and R? Remember what those stand for? Yaw, pitch, and roll. Did you happen to notice when you do those where they tend to roll around when you're in a certain tool frame? You did? No, you didn't.
But you said how it rolled around when it's in a certain tool frame.
All right. Do you remember where I
Could you
think
show us?
I told you where the 0, 0, 0 point is for the tool? Remember, for world coordinates, it's at the center of the base, right? For tool, it's right in the center of this little plate, wherever you're bolting the tool to, okay? So if I put it in, instead of in world or joint, if I put it in tool or U-tool, right there, there shouldn't be, I guess I'll check really quick. Remember how we got to frames for user frame? Not, there's a video, but I just did it. 6 setup, 3 frames, and that's after you hit the menu button. Okay.
I was about to tell you.
What?
I said, I was about to tell you.
Oh, you weren't.
I went to my notes.
Oh, you were?
I was
All
going to
right.
read them and pretend that I knew them.
So here in this menu, we're in tool frames, and before we were doing user frames, but we're going to do the same kind of thing and teach it 3 different points. I'll show you that in a few minutes. But I was looking to see if they're all cleared out. They are. They're all zeroed out. So.
But you still go to the frames.
Yes.
The setup and then frames.
Right. And then so if I, from here, from this menu, if I wanted to go over to user frames, I would hit F3 other, and it gives you tool, jog, and user. I could go down to user, but we're going to stick in tool frame this time, and they're all zeroed out. So if I'm in tool mode, okay, so not world, not joint, but I'm in tool, and if I bump the speed up and I roll around those 3 axes, yaw, pitch, and roll, you'll be able to see where those axes are that it's rolling around. Let me show you that in a second. So I'm going to hit reset default. I'm going to bump the speed all the way up to 100. And I'm going to go x-axis. So this would be yaw. And you see how it keeps the center point of where that tool is bolted to the robot? It keeps it all in one place, and it's just rolling around that axis. So there's an x-axis in here that point is rolling around that axis, right? And then here's pitch. So it's rolling around that axis now, but it's keeping that center point in one place. And then here's roll. So it's rotating around the z-axis. Make sense? What we're going to do is we're going to teach the robot where the tip of that pen is. And what that's handy for is when if you wanted to have a different, you got a couple different welders you're going to attach to this thing, right? They might have different points on the end of them where you'd have to teach that robot where it is, where that is. When I'm done teaching it, and then I show you how it can roll around those axes, knowing where the tip of that pen is, you'll see how it's useful. But the lab that this is designed to teach you to work towards is, I think on the lab itself, it says weld a 2x4, but you can use anything, a 2x4. I put a piece of unistrut up there, and I just want you to simulate using a tool frame, create a program to simulate welding that to the table. Okay, anybody, you all welded before? Anybody not welded before? If you haven't, it's fine, but we're just gonna pretend it's like stick or MIG, and when you're welding, all you're doing is coming in at a 45-degree angle. A lot of times you're pitching it that way. But I just want you to pretend like you're welding a bead along there. Pick it up, roll it over, weld all four sides of this to the table. Make sense? All right, so here's how we're going to teach the robot where the tip of that pen is. You could go in and manually teach it. You could measure straight down with a level along the z-axis, so many centimeters, and you could input that manually. But there's also a 3-point method that will triangulate where exactly the tip of that is. So all you got to do is, with the tool that you're using, find some point, and I put that red pen on the table, and I'm going to use that to teach it. But you could also use the little cross, the little plus mark on the piece of paper, any one point. And then I'm going to teach it 3 different directions. So if I'm going to use this point to teach it, I'm going to take that that pen and at 3 different angles and teach that point, put it on at another angle and teach that, and then teach that. And can use all 3 of those directions to triangulate where the end of the pen is. Make sense? And what I would recommend you do is try to space these out in like almost 45s or as close as you can to it. Depending on where you're at on the table, you might not be able to get it perfectly. But if I teach it all 3 directions like this, it's not going to be super accurate, right? The more I can spread those around, the more definite it's going to be able to triangulate exactly where the tip of that thing is. Does that make sense to you? So number 1 is what I'm going to use.
Do you always start with 1?
Nope. You can pick whichever one of these you want. I'm going to go with 1. So I'm going to go detail F2. And it has the same kind of thing. Before, when we were teaching user frame, it was origin, and then it was X and Y. And you had to teach where those axes were at a 90-degree angle to each other, right? But this just has 3 different approach points. There are different methods, like the manual mode, where you can actually put in the measurements, but the 3-point method is what you want. I'm in tool frame 1, we're in 3-point method, so I'm going to go down. I can change the comment to my initials or whatever. I'm just going to leave it. So I'm going to put it in world. Giving me a limit error, so I'm going to just move it over to where I can get to it a little easier. And it doesn't matter where on the table you teach it, as long as you're putting the 3 different points on there from the same spot. I'm going to use the joint to do this.
angle the pen will get through.
Just the tip, just to see how it feels.
That's what she said.
That would be pretty darn close. And then with the same method as last week, once you've got it there at a certain angle that you like, then you're going to hit shift record, which is F5, and you'll see that point 1 is recorded. And then it's just a matter of getting 3 different angles that are as close to at least 45 degrees away from each other so that it can take those 3 lines and figure out where the deal is. So
So the point would be away from the pen, not on top of the pen.
I'm sorry, the
Right.
point.
The point like, would be right where it is now, or when you have it over the pen.
When you have the tip of your tool touching the tip of whatever point you're going off of, you could use the plus mark on the paper or a pen like that. When you have them touching, you hit shift record.
Why do you need to have 3 of them?
Because without 3, it cannot triangulate where the end of that pen is. Do you see that or no?
I mean, I get the concept of
It
triangulation.
knows.
I just don't understand how telling it where the end point is 3.
If you can figure out a way to ask me the question that, like, I'll answer it for you. I just don't know what you're saying.
What are the, if the final point is the point we need to know and the point it needs to know, what do we tell it that same point, that end point on top touching the pen? Do we just record that same point 3 times? It's just the frame that makes
Yeah,
it
I'm going to
know
put
where
that
it
tip
touches.
on that tip 3 times, but from 3 different angles,
Okay.
right? And then it knows the distance
because
between
you're
this
in-
and where you're telling it, right? So it knows
And
where
it's
this
because
is.
you're in the tool frame that it knows.
I'm not in the tool frame to jog right now. I'm in
I
joint.
just don't understand.
But you'll see when I get done recording all 3 what it does and how it helps.
Okay.
It's kind of like upside down.
Yeah. Close. So then I'm at approach point 2 and I hit shift record. So shift F5 and it's recorded that. And I'll lift the thing up. and get it kind of to the angle that I want.
Oh, because you're changing the angle of the tool of the joint at the end there?
Right.
Each time?
Right.
Okay. I get it now.
So, I mean, think of yourself as the robot's controller.
Yeah.
So you're sort of like a
I
brain,
get it.
but you're also really dumb.
So you're
So-
changing the angle that
Right.
the joint's at to go in.
Right. If I tell you where this line is,
Mhm.
it knows where that line is
Mhm.
potentially forever.
Yeah. But if you have it
Somewhere
coming
between
in-
that and this, those two lines are going to intersect
Okay.
at that point.
So it's
Right.
the angle and where those angles meet.
Yes.
In the middle.
Yeah.
Okay.
And then a third one just improves accuracy. So then I could tell you two lines.
So it's not.
If I
about-
gave you this,
Yeah.
you would know that where that intersects here, but you also need kind of a third
So it's
dimension.
not about it touching the pen, it's the angle.
Right.
that
And it doesn't matter
touches
which
the
angles you
pen.
give it, but it's always going to be able to figure out
Okay.
where they meet. Okay. So I've got tool frame number 1 recorded. And you're going to have to do this with no matter what kind of pen or marker or anything you have in there as your tool, because they're all going to be a little bit different lengths. But that's how you teach it, where that is. And then it tells you X, Y, and Z where the end of that point is. All right, so now I'm going to go into a program. Create, test, enter, edit. And here's how this is so helpful. So I'm gonna put it in World. No, I'm gonna go to Tool. But what I need to do is make sure that the tool frame that I am calling is the same one that I just created. So I'm gonna hit Shift Coordinates, and I'm in tool frame 1. But that's the important part. You got to make sure that that's the one that you're using. And then in your program, you have to make sure you're in that same tool frame that you created as well, right? But here's where it gets cool. So now that I've told it where the end of that pen is, it will now rotate the whole thing so that the tip of that pen stays in one place. It wasn't doing that before. Remember, it was keeping the center of where it bolts on. It was keeping that in the same place. But now if I bump up the speed, and I go, here's yaw. See how it keeps the tip of the pen right there, no matter what you're doing? It looks like, so do you remember for this robot, the x-axis is horizontally this way because it's actually backwards. But if this is the x-axis, like this, it's taking the tip of that and rolling it around that axis. Does that make sense? And then if I hit just threw that away, the pitch, which is the Y or joint J5, that will rotate it around the Y axis. So when I hit that one, you'll see it kind of rotate around as if there were an axis like this, right? It's going to rotate the tip around that. So here's pitch. See how it's doing that? I mean, until it can't reach it anymore. But it's really helpful for when you're creating a program like we're about to do with the, and I'm just going to run through real quickly and show you, because it's kind of cool when you run the program to see how it uses that frame to roll it around where you want it. But all right, so here's, oh. All right, so what I'm doing is going back and forth from world to tool, right? It's easier for me to move it straight up and down with those straight axes in world. And I just moved it up and over to the right a little bit, or my right, and got it above, hovering where I want it to go down next. But before I put that point in, I'm going to switch it from coordinate to, from world to tool. And now which axis would I need to roll around to get it to a 45 to make that bead? For this robot, that's the Y. So if I hit plus pitch, which is this J5 plus Y, it should just roll right around that axis for me. Oh, minus Y. But it keeps the tip in one place. So I'm gonna try to run this now. See what we get. Oh, 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 oh.
It's lucky that went
Did you
into
see the
hole.
mistake that I made?
Yeah, you're lucky it fell into that hole.
So what was my mistake?
Yeah.
I went straight from, I welded this bead and then didn't put a point straight up here before I came over here. So I went straight from there over to, insert a line. I know.
Between 3 and 4.
See if that fixes it. That's more better. All right, so that's what I want it to look like, except I want you guys to weld all 4 sides of it. Use the tool frame. Good? All right, you see the difference between the tool frame and the user frame? Could you explain the difference to me? Maybe? With the user frame, we're resetting that 0 origin point that's in the middle of the base. With the tool frame, we're resetting the 0 point that's in the middle of this thing, right? We're just resetting the defaults, but it allows you to do 2 different things. So, all right, any other questions? Ready, break.
I was gonna say it again, but I don't know you.
I didn't go my friends classes like this. We're supposed to get slammed. Sleet, snow, yeah, all of it. It's all coming down. Right up here. And right as it all was starting to turn to slush.
It's Illinois, well,
I know.
you're gonna be screwed over by the, every.
To tell you the truth, in Canton, we had an ice maker. It was one of the penguin ones. We had to get it. They had a penguin.
There's only a penguin.
They had penguin stickers all over. That's why they call it. Oh, gosh. Well, anyway, they had to get it fixed every year because of how big our climate was changing. All the temperatures. It up in the winter, up in the summer. So like 3 years to get just downside. It sucks.
Damn thing.
I believe it's called twice the ice. Where you can get a 10-pound bag for $1.50.
I don't know.
Yeah, why is something price for that?
Ice.
Buy ice.
All right, Jack, I'm gonna have to.
All right.
Are you gonna be in here Friday morning?